In this video, we're going to look at how to graph the cosecant and secant functions, which are just the reciprocals of sine and cosine, so they'll use a lot of the same information. For the process of drawing the graph, first you're actually going to sketch the same starting points we used for sine or cosine graphs. Make sure you're using the sine starting points for cosecant graphs and the cosine starting points for secant graphs. So pretend it is just a sine or a cosine graph at first and plot the starting points normally, but do not connect those dots. What you will do instead is you should have three different heights of points. There should be a very tallest one, one in the middle, and then ones at the bottom. The ones in the middle are the ones that will create your asymptotes in the graph. Now, normally these are on the x-axis, but if there is a vertical shift up or down, it will move those points off of the x-axis. And then the highest points, the ones that we call the maximums, those should have parabolas facing up. And then the minimum points, the lowest points on the graph, those should be parabolas that are opening down. So we're still using the same starting dots, but instead of connecting them, use this process here. So first we'll look at the parent function for cosecant, which means without any transformations being applied to it. Since we don't have any transformations, we can use the same scale we normally do. So I'm going to have pi over 2, pi, 3 pi over 2, and 2 pi. And vertically, every second box I'm going to do is a length of 1, so 1, 2, 3, 4. So this is based on the sine function. Cosecant is the reciprocal of sine. So you need to remember the starting points for the sine graph. Usually there's a dot at 0, 0, and then at the first tick mark it hits a height of 1. Next tick mark it goes back to 0, back to -1, and then this pattern just keeps repeating. So I'm going to continue to extend these dots. It hits this highest point and then it would keep going down, and then back to the top, and then back to the bottom. So what's different here is if this had just said what is y equals sine of x, I would have drawn those dots the exact same way, and then I would have connected them with the wavy motion. Since this is the reciprocal function, you instead need to go through and perform the process of drawing the asymptotes and the parabolas. So looking at our basic sine graph, we can see that there are the highest height points, the middle height points, and the lowest height points, just paying attention to the y values. For the ones passing through the middle height, these are the ones that should create your vertical asymptotes. So just lightly draw a dotted, or maybe using a different color, vertical line passing through those dots. Next, we'll look at the points that are at the top and the bottom of the graph. For the highest points, the one we call maximums, we draw a parabola that is opening up, and then make sure you do not cross those asymptotes that you've sketched in. So every time you see a dot at this highest point, parabola up. Likewise, for all of the points at the bottom, draw parabolas going down. Again, make sure you never cross the asymptotes that you sketched in. This is enough to show two full periods. If you ever need to, the graph kind of cuts off, but I could show half of this parabola as well. I could even show the half one on this side. So if you need to use a little bit more space because you're not showing enough of the graph, you could show those to add a little bit more to the width. But the two parabolas facing up and two parabolas facing down, that is enough to show two full periods there. So now we will look at the parent function for the secant graph, and this one is based on the cosine starting dots, since these are reciprocals of each other. So again, we're just going to start off by pretending this was a cosine function, which means we usually have a dot at a height of 0, 1, and then pi over 2, 0, pi, -1, and these dots just keep bouncing back and forth between the maximums and the minimums, filling the width of the graph. So for the tick marks going this way, same exact thing. As before, we're not going to actually connect these dots to make the cosine graph itself. Since we're doing the secant one, we're instead going to go through and draw our asymptotes at all of the dots in the middle height. And then for all of the maximums, we'll draw parabolas opening up. And for all of the minimums, we'll draw parabolas opening down. So make sure on your notes and your examples that you are getting coordinates landing at the exact same locations. It's very important to have the scale labeled on your graph because we need to be able to see where do you have an asymptote occurring. What is the x value? Pi over 2, for example. Another one at 3 pi over 2. We also need to see these exact dot locations for where I have these parabolas starting, the vertex of them. So what is the coordinate of each of these vertex points, vertices? You should be able to read on your graph that it's at a height of 0, 1, for example. Now we'll look at the trickier cases, what you'll actually see in your worksheets, where you have to take that original function, those starting points, and we have to perform transformations on the graph. So these transformations, we have an a value of 2 and a d value of 1. That means we're multiplying the y-coordinates by 2 and then adding 1 to them. Make sure you do the multiplying before you do the adding. So cosecant is based on the sine graph, which means usually I have a dot at 0, 0. If I double the height and then add 1 to it, we end up at this height. Next, at the first tick mark, usually it has a dot at a height of 1, but I am doubling that height and then adding 1 more. So it ends up here at a height of 3. Then the graph goes back down to a height of 0. Double plus 1 ends up here. And then on the next tick mark, it starts at -1 normally. We are doubling that and then adding 1 to it. So -1 times 2 plus 1 ends up equaling -1. Now we have the 3 dots for the heights of our graph. If we just keep extending, what happens whenever you hit a minimum, it bounces back to the middle and then back to the maximum. And on this side, same thing. It went from the maximum to the middle. Next tick mark, it would go back to the minimum and then middle, maximum, middle, minimum. So it's the exact same process. We're just pretending this is the sine graph for drawing those dots, but now instead of connecting them, we'll do the asymptotes and parabolas. Out of the 3 heights I see things occurring at, the middle heights will be my asymptotes. These would have been on the x-axis, but because this graph has a vertical shift of 1, it has moved them up to a height of 1 instead. And then for each of your maximums, draw a parabola up. And for each of the minimums, draw a parabola down. We have enough of the graph shown here. This is 2 full periods, so we could fill in the halves on the end, but that's enough for grading purposes and accuracy for how much I want to see at a minimum. This one is the more complicated case where you have a b value. So whenever there's a number for this b, this is where I like to find the period of the function. So 2 pi divided by the b number. Now do note that saying 1/2 times x is the same as saying x divided by 2. Dividing by 2 is the same as multiplying by 1/2, so make sure you're comfortable with recognizing what the b value is in this case. But then instead of dividing by 1/2, you might want to think of this as you're multiplying by the reciprocal rule. It's a lot easier to compute that way. So instead, I was saying, what's 2 pi times 2? And that's where I got my period of 4 pi. Now I like to take that number and divide it by 4. That creates my first tick mark. And then it's just that number times 1 for the first one, that number times 2 for the second tick mark, that number times 3 for the third, and that number times 4 for the fourth tick mark. So I ended up with a tick mark of 1 pi, 2 pi, 3 pi, and 4 pi. Vertically, I'm using the same scale I almost always use. Now that we've taken care of that, we can actually just ignore the fact that we have a transformation for the horizontal stretch or shrink. So we can instead just say what's normally happening at the first tick mark in terms of the starting dots. And the only thing we'll have to move is according to this d value of -1. So that's going to move the heights of our graph down 1. So secant is the reciprocal of cosine, which means we'll be using the cosine starting points. Usually cosine starts at a height of 1, but this graph has a vertical shift down 1, so it's going to move it to here. Again, remember I changed the x-axis tick marks, but usually at the next tick mark, the graph is at a height of 0, so I'm still going to the first tick mark. I've just changed what that x number represents now, but I need to shift the height down 1. And then at the next tick mark, it's usually at a height of -1, but we're moving it down 1 more. So now it's down to this height, -2. And since I see my 3 heights, now I can just keep extending the pattern of having it bounce between the maximums and minimums instead of recalculating each point individually. If this question had said, what is cosine of x over 2 minus 1, I would just connect those dots and I would be done. But since this is the reciprocal function, we need to take the middle heights and draw the asymptotes and the parabolas. So here are the middle height x values. And then for our maximums and minimums, the challenging part on these is applying the transformations. It's not the actual sketching of the graphs themselves. The only thing I need you to be very precise with is the location of these dots that I've shown and the location of those asymptotes. So do make sure you're including them on the graph and make sure that your parabolas are facing in the correct directions. And that's it for this lesson.